Chapter 18 is called Toward a New View, the Scientific Revolution and the Enlightenment. This chapter focuses on intellectual, scientific, philosophical developments in Europe right during the time of the absolute monarchs and after that. And it concludes with a section on the political impact of all of these new ideas that float around in Europe at the time. Let me give you the dates to write down. This is a period that takes place between about 1650 roughly and about 1789 or so. That's the beginning of the French Revolution. So it's the 17th century and the 18th century. And when we say toward a new worldview, it really means a modern worldview. This is the time in history where you have the development of science and a secular scientific worldview, which really dominates the modern world. And it replaces, you should write this down somewhere, primarily a religious or theological worldview. And now you have a secular and scientific worldview. This affects almost every area of life: politics, art, the way people saw each other, government. So it's a pretty momentous development. Okay, let's get into four main ideas here that the scientific revolution is about. So put this maybe at the bottom left of your first page of notes here. Basically, the main ideas of the scientific revolution is that all areas of life were affected by it, from science to religion to government to philosophy. And I said that a minute ago, but you can make sure you write that down. The second main idea of the Sci-Rev is that it was international. It happened all across Europe, and there was correspondence and relationships between these scientists, and they built on each other's work, so it wasn't confined to one country. Third, most people in Europe, despite this shift towards science, most people stayed very religious. This was not the beginning of atheism. One or two, several prominent people lost their faith and became atheists, but most of Europe and most scientists were still deeply religious. They just interpreted the world in a new way. And then lastly, fourth main idea is that a lot of these scientific developments were funded and sponsored or patronized by absolute monarchs that used science as a way to promote their own power and their own position in the world, and they wanted to back the best scientists available. This is just like in the Renaissance, how powerful families like the Medici wanted the best artists to be on their payroll. It made them look better. The same thing is true here. Important political figures use the scientists to promote themselves, and in the process, great science is developed, so it's somewhat mutually beneficial. All right. Why is the Sci-Rev so important historically? Placing it in a historical context, this is the first section of notes here. Basically, this phenomenon was unique to the West, to Western Europe at the time. And the beginning of this new worldview, it sort of separates the West from other parts of the world. And in some ways, it still does. And people, as you know, still come to the West, to America and Europe, from all over the world to learn about science and technology. This is an area of human history where the West has always kind of taken the lead in terms of science, technology, engineering, mathematics. If you want to study those subjects today as a college student or a graduate student, typically you got to get your way to Britain, Germany, the U.S. This is still where we kind of lead. All right. Let me read you a little quote from the textbook about how important the scientific revolution is. It says, "A noted historian said that the scientific revolution outshines everything since the rise of Christianity and reduces the Renaissance and Reformation to the rank of mere episodes, mere internal displacements within the system of medieval Christendom." So it's a big deal, all right? There's two interpretations. Internal, this is that basically scientists built on the work of other scientists, and the whole development of the Sci-Rev was among scientists themselves, kind of working, just among each other. The second theory is external, that there was external causes of it, that there were economic, social, and religious factors that allowed this to happen when it did, primarily political stability. Now that absolute monarchs are ruling and there's no more great religious wars, and the absolute monarchs have money and are willing to spend it on science. So there's two theories. They're both happening. None of them are right or wrong. It's not exclusive. All right, let's go back to what scientific thought looked like in 1500. pre-scientific revolution, which was really still based on the 4th century. Ideas in 1500 had not changed in basically over 1,000 years since almost the beginning of Christianity, and all of that was based on the work of Aristotle, the famous ancient Greek scientist and philosopher. And Aristotle's work was really the earth-centered universe, okay, the geocentric theory. He also believed in these elements. 4 elements kind of ruled the scientific world: air, fire, water, and earth. In this geocentric model, and I put a picture of it right here, he also said there are these 10 crystal spheres. The planets are like 10 spheres. Heaven is beyond the 10th sphere, and you can see that out there. The habit is in Latin. The habit, DEI, is God. The habitation of God. So it combined science, astronomy, and religion all in one theory, with the Earth in the middle. And you can see the Latin names of all the planets rolling through the solar system with the Earth in the middle. This was Aristotle's theory, and it made sense because it's how the system appears from our position on Earth. It looks like we're not moving, and everything else moves around us every night. Okay, and also, why is it so accepted? That's one factor. But two is that it was consistent with Christian views once Christianity became the dominant religion in the world, that God is at the farthest ends of our solar system and man is at the middle of it now, because we're the highest form of creation. So it fit with what we observed and with the dominant religion at the time, at least the interpretation of it. And it's the geocentric theory. Okay, the other person that had also said that, really going back even a little bit before, was Ptolemy, Ptolemy, silent P. And so the work of Aristotle and Ptolemy really focused on the geocentric theory. And here's another model of that. Okay, so Earth-centered. And this is how it seems to, from the natural point of view, looking at it with the stars at the end. So the geocentric theory is, of course, wrong, but it persisted for 1,000 years until Copernicus. And you see his years, and he was Polish. Okay, so every scientist I teach you about, we're going to go over their nationality so you can see how international it is. He was a Polish clergyman, a priest, and also, was a scientist and a priest at the same time, which is amazing. And his theory, landmark theory, is the heliocentric theory, also known as the Copernican hypothesis, which totally transformed the whole view. This is now the sun-centered universe with a fixed sun in the middle of the universe, and everything revolves around the sun, heliocentric. He said the universe was a lot bigger than we ever thought it was. As a clergyman, he was not able to publish all these radical theories easily. In fact, he didn't publish his work on the heliocentric theory until his death. It was published basically on his deathbed for fear he would be, harmed or arrested or killed or who knows what. So this is how dangerous some of these new ideas were at the time. The reaction from the religious leaders at the time were very harsh. Luther condemned him. Calvin condemned him negatively. The Catholics actually at the time condemned him, but were a little slower to do so. The Protestant leaders were much more against him at the time than anyone else. But that's going to change, actually. And you'll see over this section, the Catholics are going to become the big persecutors of scientists, and the Protestants are going to sort of loosen up a little bit. So here's the heliocentric theory, according to Copernicus. You can see it. Okay, but radical stuff, all right? Next section, from Brahe to Galileo. So all these guys do build on each other's work. Tycho Brahe. Brahe, what's up, Brahe? Sounds like a frat guy. Tycho Brahe is a Danish astronomer who built an observatory working for the King of Denmark, again, sponsored by important people now, and his main contribution was that mustache that he has. No, it's about data collection. He collected data, he observed natural phenomena for decades, wrote it all down, produced this incredible volume of data, and then didn't really know how to make sense of it. He was using Copernicus's new theory as his foundation. Anyway, he built all this data up over the years and then turned it over to the next guy, Johannes Kepler. But look at Brahe for a minute here. This guy was incredible. He was like a brawler. He had he busted his nose in some fights that he got into. Just a fascinating guy. Let me read you about an imposing man who had lost a piece of his nose in a duel. Yeah, dual, yeah, and replaced it with a special bridge of gold and silver alloy. Okay, he was a nobleman who exploited his peasants arrogantly, but approached the heavens humbly. Anyway, what an interesting guy here, all right? Tycho Brahe, sponsored by the King of Denmark. So then he turns all his stuff over to Kepler, who's a German, okay, who expanded on this work of all the observation of the solar system, and he came up with the 3 laws of planetary motion. One, planets are in elliptical orbits. They move in elliptical orbits. Got it? That's the first law of motion. The solar system is an elliptical, not circular, elliptical. Okay, the planets do not move at a uniform speed. 2. And 3, the time of orbit relates to their distance from the sun. So the time it takes you to orbit relates to how close or how far you are from the sun. This makes sense, of course, if you look at the elliptical nature of the orbits. Okay, so that's Kepler. So they've built on each other's work so far, 3 guys. There's Kepler with his scientific instruments, okay, and his giant collar. So anyway, the guy looks very serious. All right, next guy, Galileo, Italian. He was a Florentine. He lived in Florence. Okay, big stuff. Galileo's main contribution here, lots of them. First one is the scientific method. He was the first to believe in using experiments to prove things, to have controlled experiments. He studied gravity for years. The myth or the theory, some people think it was true, is that he would go to the Leaning Tower of Pisa and drop different size balls off the tower because it leaned, and then he would have someone at the bottom seeing how did they land at the same time, or did the heavier ball fall faster? And of course, he comes up with the laws, his theories of gravity, which says that there's basically things fall at the same speed, regardless of their weight in a vacuum. That's what he said. Okay. He also related concepts of acceleration and force. Okay. He came up with the law of inertia, which said that motion of an object will go on forever and ever unless it's acted upon by external forces. Things will just go on. So think about, in a weightless environment where there's no gravity, things just go on forever. He invented one of the first telescopes, and he studied the planets with it. He studied the 4 moons of Jupiter. He discovered the 4 moons of Jupiter. He discovered the shape of our moon, the Earth's moon. He discovered the Milky Way. In fact, some of the moons of Jupiter are named after him. There's moons named after Galileo, actually, because he discovered them. Who was his patron? The Medici. They switched from art to science when it became fashionable to do so. And the Medici, the Grand Dukes of Tuscany, that's what they were known at the time, the Grand Dukes, still around in Florence, they sponsored him. And so you see the connection here between science and art. Galileo was he'd take them aside, these little Medici kids, and he'd tutor them in science, and he was like a court performer. He did science experiments that were entertaining and exciting. He made science like art and made it very popular among the Medicis and the upper class of Florence. Sadly, Galileo was persecuted heavily by the Catholic Church at the end of his life. He was called in front of the Inquisition and had to go to Rome, to the Vatican. He was put on a sort of a sham trial, and he was forced to recant everything that he had taught in his life about how the Earth is not in the center of the solar system, and how the Earth is moving and the sun is in the center. All of these things that obviously go for granted now. He had to recant, and he spent the last years of his life under house arrest in Italy. He was not killed. He was sort of like imprisoned, but in his own house. Okay, that's Galileo. Incredible. So the Catholic Church, I looked this up a few years ago, the Catholic Church did not admit that they were wrong about Galileo until the 1960s. It took that long to basically formally apologize and say that, yeah, he was right. Okay, he was again put on the trial at the Inquisition, and it took better part of 300-400 years for them to recant what they did to him. Okay, all right, let's go on to Newton, Isaac Newton, good-looking Englishman. So he's an Englishman. He took everyone's ideas and put them into one single explanatory system. Okay, he's like the synthesis guy. Get that word down somewhere. Synthesis. All about gravity and laws of motion and all this. Okay, this is more stuff for science class, but we'll just give you the overview. So he's deeply religious. He's one of these guys that never gave up his religious faith, okay? He's interpreted everything from a Christian worldview. Incredible work ethic, intense work ethic. His main book was the Principia, the Principles, okay? You can see it written in Latin here, the principles of mathematics and philosophy and the natural world. Okay, this book combines all the theories of everyone else into one law of universal gravitation. Universal gravitation, studying all the different planetary motions. He was also a big fan of what we call alchemy, which is kind of like the mixing of science and religion with a little like a superstition mixed in there, with like developing elixirs and using various metals to kind of treat diseases, and believing in metal work as sort of like the elements are what cure us. So there's right down the no alchemy. Alchemy, so it's like a mix of somewhat religion, science, and medicine. And he was one of the main practitioners of that. All right. So there's Isaac Newton in his book. Scientific. What are the causes here of the psi rev? Let's go back into that. Again, the internal causes of scientists building on the work of other scientists. So the famous quote by Isaac Newton was, "If I have accomplished anything, it's because I stand on the shoulders of giants." So he gave credit to the people that came before him. We stand on the shoulders of giants. Just think about that for a minute. As a Westerner, as an American, all the people that have come before us to make life better, physicians, scientists, political stability, all the things we take for granted maybe, freedom, we stand on the shoulders of giants. Medieval intellectual life, believe it or not, there was actually universities, remember that, after the Black Plague. They promoted free inquiry. They had science established as its own separate branch of knowledge, distinct from theology. The Renaissance was big in terms of promoting patronage and support for artists and scientists. Okay, the study of the ancient world. They brought back the idea of Aristotle and then began to question it. So Aristotle, of course, from the classical world, as Ptolemy was, and then they studied them and then expanded on it and reinvented their ideas. So the Renaissance is actually big as an intellectual movement. Navigation and overseas expansion was a phase in this. Think back to the Age of Explorers and all their instruments. Institutions like this, like Gresham College in England, okay, this is a college, and they held competitions for people to prove things and have advancements first. The people at Gresham College were obsessed with latitude, okay. They were always working with leading merchants and shipbuilders, okay, to promote scientific activity and exploration. The Gresham College started this thing called the Royal Society of London, which is an international scientific organization today, but was obviously English then, where you want to join this society. They advise the king. They advise the monarch. They publish papers. They hold meetings. If you're any good scientist in England, then or now has to be part of the Royal Society of London. Okay, so you've got governments and colleges all promoting this and helping finance it as well. All right, let's go on. Better instruments help the scientific revolution emerge, like the telescope, the thermometer, clocks, microscopes, inventions. Okay, promote and push forward the air pump, the pendulum, the barometer. These things that guys are inventing push forward the development of science at the time. All right, so let's go into Francis Bacon. He's English. Francis Bacon is an Englishman who builds on Galileo to even more talk about the scientific method, or the empirical method, we call it. But Bacon's big contribution is known as inductive reasoning. He called for inductive reasoning, where you start with specifics, details that you've observed. And based on those details that you've observed, you come up with general theories that apply overall. So you start with a specific and you move to the general. Okay? And what argument did he use to convince people to support this new approach? He goes, look, nations that are behind science and that promote science and embrace it are going to become rich nations and powerful nations politically. He saw the connection between advancing in science and advancing in wealth, prosperity, and stability. And he goes, look, this is how he convinces the King of England, who was actually Charles II at the time, let's move forward here. It was one of the Charleses, I forget. Anyway, that's the thing. This is powerful, okay? Science equals power. Let's go on to René Descartes, a Frenchman. Okay, thank you, Descartes, because you get to take 10th grade geometry because of him, because he invented analytic geometry, all right? So this guy, not only does he invent geometry, he was supported by the Queen of Sweden. So again, they found support among different monarchs. Now, he had to go up to Sweden to work because the French kings were not quite sure about him yet. This was early on, and science wasn't incredibly popular, especially in Catholic countries. He actually found support up in Northern Europe. He came up with deductive reasoning, write this down, where you start with general accepted principles and then you move to the specific. So if it's true for the whole, it's true for the part. Okay, so deductive and inductive reasoning are opposites in some ways. You move from specific to general in inductive reasoning, and in deductive reasoning you go from the general to the specific. All right, universal doubt. Universal doubt is the second thing. You have to doubt everything until you can prove it. So he's a skeptic, kind of like Montaigne. He said everything in this universe is matter or mind. Matter and mind. The physical and the spiritual worlds. This is the way he saw it. It's called Cartesian dualism. Okay, Cartesian dualism. All of the universe is mind and matter. Role of religion. What role do Protestants play? After 1630 or so, Protestants really tended to support science. And they said, look, science is a private matter. You have liberty of conscience. Most Protestants believe that, of course, about religion, and they extended it to views on science. And they became known as sort of like, if you want to be a scientist, you got to get yourself to a Protestant area like northern Germany, or Prussia, or the Netherlands, England, Denmark, Sweden. These are the places that you want to end up as a scientist, and these are the people that support scientists the most. Catholics eventually became more anti-science, and they associated science with being in Protestant countries who they hated, so they persecuted scientists like Galileo. And this becomes a big part of the Counter-Reformation too, that you go after, unbelievers and dissenters with the new Roman Inquisition, as they did with Galileo, as I said. So Catholics kind of get this bad rap for being anti-science once we hit about 1640, 1650. Okay? What do we got going here? Consequences of the SciRev. All right, long-term effects of the scientific revolution. Number one, the international scientific community developed, and that's still thriving today. If you're a scientist, you travel the world typically and hear other lectures, give lectures. There's a lot of, you work with people from other countries quite a lot. When I was in college, I worked as just like a lab assistant in the lunar and planetary lab at the U of A. And these scientists were always traveling to Europe, and they were going to Poland and meeting with Russians, and they were always working on things in giant international teams. So that's still true. Science became very competitive. Whoever could be first to do something, was really important. All right, so there's a competitiveness to it. All right, let's see. Secondly, the scientific method. That's the review from Galileo. Here it is. This is the steps of the scientific method. Look at it. You probably learned this starting in kindergarten. But it's big. It's a whole new way of getting knowledge. Knowledge is no longer based on tradition or sacred texts or religious documents. In terms of advance, for most people, they're moving away from the Bible as a science book and leaving it as a religious book, but not a science book. And now the way we get knowledge is we study something, we experiment, we have a hypothesis, we draw conclusions, and we report results. So it fundamentally changes the methods of gaining knowledge. Okay, next. The scientific method in the revolution really did not make a difference in the life of the common people for centuries. So in terms of long-term effects, this was all kind of like theory for a while, and scientists talking to other scientists. Nobody really made practical inventions until the 19th century in terms of sewer systems or clean water or real advances in medicine. This stuff doesn't really happen. So for a long time, the SciRev is mainly theoretical, which is the last point here, pure versus applied science. Pure science is theory only, which is basically what the SciRev was. Arguments among scientists. Applied science is practical science, where you actually do things that improve society. Again, inventing, sewer systems, vaccines, all this kind of stuff that again, is such a part of our world. That doesn't really show up until the 18th and 19th century. The Sci-Rev here in the 1500s, 1600s, and 1700s is primarily pure science. And there's still a debate among scientists as which one is the better science. Is it better to be a pure scientist and just stay in the realm of theory, or do you want to be practical, like an engineer-based scientist, okay? So that's the long-term effects of the Sci-Rev, a fundamental change in the way some people viewed the world, and of course it's never going to go away.